Let's start off with some recollections. I want you all to remember a time when you were working on a project that you really cared about and took a whole lot of time to build, right? Like those really frustrating hours and tens of minutes when you just want to fix a bug or get a really small feature in, and it takes a whole day to build it and run tests, and how much that ground you down. Well, imagine there would be like a moment in time when, oh, that went away, right? The project you love that took 2 hours to build and run now takes a couple of minutes. You can get your stuff in super quick, super fast. This is what we're going to talk about today and how we build things at Google. Starting from a very simple idea of this could be way better, this could be way faster, this could be way simpler, and how to get into production. My name is Andrei Timofticiuc. Everyone calls me Timo. I encourage you to do the same. I'm a staff software engineer at Google and the current tech lead for iOS at Fitbit. Based off of the awesome Bucharest office in Romania, we have a large swath of team. We cover design, product, engineering, testing, you name it, we got it. We lead very large-scale projects out of this office, which impact millions of users daily. And today we're going to talk about one of those projects, which we essentially rolled out super incognito. It affected everyone within the company and all of our users without them noticing, which was music to our ears. So what we're going to talk about today, 3 points. 1, the challenge. We were tasked with migrating 2 large-scale mobile apps, namely the Fitbit iOS and Android clients, from our current infrastructure into the Google one. These projects are 10+ years old, tens of thousands of source files ranging across multiple languages, custom scripting, custom tooling, custom distribution channels. Obviously, everything was custom made for us. And we had to revamp the entire thing. What was the solution? So we had to find a system and a process which enabled us to do that while maintaining our developer workflows and our features being released into production. Mind you, we had to do this without disrupting the company, right? It had to be business as usual while we did all of this in the background. And finally, the results, right? Like, what did we have to show for it after all this time, after all this work, after migrating 2 large-scale projects from one system to another that were 1A completely different. So let's get into it. The challenge. How do we safely migrate or build infrastructures without our users noticing? When you think about it, why would users care about build infrastructure? What's the deal? They just want to use a mobile app, right? They tap on it and it works. That's great. Well, here's the deal. The build infrastructure basically dictates more or less everything in the app, right? You build source files, they link together, that results in a binary, and it runs. But say you accidentally build for, I don't know, a very weird architecture. Let's say that'll work for 80% of your users, but you're going to have 20% of users that are not going to be able to run that application anymore. 20%, or let's not 20, let's say 0.2%. Sounds small, right? But then you scale it to millions of daily active users, and you've got yourself a production incident. So, 0 room for error. Getting a large application into Google's ecosystem. It was the first time something like this was attempted and successfully delivered. Like I previously said, tens of thousands of really, really old source files. Those of you that work on legacy projects know what I'm talking about. You always have those areas of, oh, we don't touch that code, don't even look at it, it's gonna crash. That file is 12+ years old, written by the former CEO that left 20 million years ago. Don't. So a lot of skeletons in a lot of closets, most of which we didn't even know existed. And we had to migrate the entire thing and ensure that we're successfully delivering it. And most of all, custom tooling for our CA and CD. As most companies, we ran on Bitbucket with Jenkins, plastered with millions of Python scripts with Ruby, and there was some bash, and there was some script written by someone that wasn't in the team anymore. So a lot of unknowns that we just took for granted. We had to migrate from those as well. We thought of it in three main stages. First of all, started from the user's perspective, the mobile application. As far as the user is concerned, there is a finite amount of critical user journeys that we had to maintain, that the users would be able to still correctly consume the app, and so they would be happy with it, right? For all intents and purposes, from that perspective, nothing was supposed to change, right? In the middle, we got CI/CD and developer productivity. This already affects our internal development, right? How we build our apps daily, weekly, nightly builds, how we distribute them to internal testers, and most importantly, to not affect all the feature developers that were committed to building and delivering the features they were supposed to, right? There's a roadmap. When we started this migration process, sure, this was priority 0, but at the same time, there's also multiple priority zeros of delivering this and that and aligning with device launches and such. We could not affect that. Our main quest was to do all of this and at the same time train the engineers to use this new system without disrupting anything. And at the lowest level is basically where we did all of our changes. So dependency management, how we pull in libraries, how we pull in third parties, how do we integrate with assets, the build system, how everything gets compiled and linked together, and making sure we're using the right set of flags for runtime and compile time. You know what I'm talking about. Testing. Even though the project is quite large and, okay, old, maybe not old, it's like a teenage project, there's a plethora of tests. So unit tests, integration tests, UI tests, all of that still had to run after we did this migration. So it wasn't just about migrating all of the code bases for the mobile applications. It was about migrating everything around them, and that included tests. That included discovering new ways how to do our UI tests, for example. We used a certain piece of infrastructure, Google had a different one. We had to adapt. For those of you super happy with software engineering and product management and project management, you would have heard the phrase herding cats. That is essentially what we had to do for the better part of this project. We broke it down into three main phases: build, run, and release. Build phase. This essentially meant we had to ensure that 100% of all source files were migrated to the new build system and were outputting the same binaries as compared to the old one, right? So that meant taking everything that we had and building it in parallel using the new build system and ensuring we had the same output every time. Okay, we got our binaries, this is great, let's run them. It crashes on launch, why? Lord knows why, so let's find out. The run phase essentially was a mad dash of everyone and anyone else who wanted to be in on this project of just testing the app, testing CUJs, running any kind of UI test that we had. And this is what I mentioned before, the testing phase. This was critical for us to discover all of the runtime issues. Because, okay, you built the app, it's compiled, and it's linked, and it's running. But there's so many other things that could be missing, right? You might have incorrectly injected some compile time flag that changes some behavior. You built for the wrong architecture. Some weird screen size isn't rendering correctly because of some parameter to some library and some flags super low level. All these things we had to find and ensure that they were not happening anymore. All these issues, right? So that's where the run phase comes in, with everyone, boots on the ground, testing the app, and running all of our UI tests, unit integration, ensuring that everything passes. Finally, release. This is where the cookie starts to crumble, okay? We got our app, it's building, it's running, it seems to be working. The final challenge was getting it code signed, making sure the entitlements and manifests are correct, and essentially uploading them, right, to the Apple and Play Store from the Google infrastructure. This was the final challenge because there's only so much we can control within our sphere of influence, right? For Apple, for iOS apps, right? You submit it and it goes to the internal Apple review process, and they might say, well, actually, you have a misconfiguration somewhere in some source file, or you might be using some flag that you're not defining correctly. Luckily, we didn't have any of those issues, surprisingly. That made us very, very nervous because, in my opinion, leading this project, I was afraid of unknown unknowns. What is it that we're missing? Why is it so quiet, right? This was something that we did across 150 plus engineers. I am not joking, I have the names for everyone, and across 20 plus teams and all the time zones. So we were spread across Bucharest, London, New York, Boston, San Francisco, all around the world. This was a 24/7 project with everyone chipping in equally. And, as previously said, without disrupting feature development and our release cadence. We essentially brought this up to leadership as this is the priority zero project, and it was treated as such. But like I said, we only caveat that, okay, we still need to deliver. We can't pause development for as long as this will take, essentially not knowing how long it might take, right? It could take a month, it could take a year, it could take a decade. We could come to a point and say, like, this isn't feasible. Screw it, let's just rewrite it, right? But no, we pushed forward, nothing was affected. We moved in really, really small increments. So this is a metaphor I like to use a lot because it's essentially how it felt for our users, right? So imagine you're driving a car down the road, okay? Imagine that car is the mobile application. What we did was the equivalent of changing the tires, transmission, and engine of the car while you were driving it, and you're not noticing anything. You arrived at your destination, super fine, happy and dandy. You left in a Toyota Corolla or something, and you ended up in a monster truck. You didn't even notice one thing. So that was a great measure of success. Now, after going through the challenge, and it all sounds super scary and weird, and oh my God, how did we do any of this without breaking everyone's stuff? The solution was surprisingly straightforward. So obviously, we needed one system to dictate this entire process. And that system is Bazel. Ta-da! For those of you unfamiliar with it, Bazel is Google's open source build system. It's essentially the one used for public, and it reflects the internal build system used for everything at Google. And I literally mean everything. It doesn't matter if you're compiling assembly or some pseudo language or you invented over the weekend. You can plug it into Bazel. As the motto stands, fast, correct, choose to. I honestly believe that as engineers, we have a long way to go till we create better puns, but it is what it is. And it's correct. It is both correct and fast, as long as you enable it to, as long as you use it correctly. And we'll get into that. So what it does, and essentially how it helped us with this project, it standardized the development practices across both platforms. We were no longer doing two separate migrations in parallel. We were thinking across a single timeline with multiple common goals, okay? So, share development practices across platforms and languages. This is by far the biggest strength of this system. It has a dedicated community behind it. We initially thought like, okay, it's open source, so maybe, maybe not, we'll see how it goes. And the community was amazing. For Android, when we started the migration process, we had to update certain rules. We had to submit a feature request that went pretty low in the guts of the system. And it got reviewed and it got approved and essentially unblocked us super early in the migration process. It encourages engineers to think in bite-sized pieces. You'll remember how we're all taught in high school the divide and conquer programming paradigm, right? Just break everything into small, small pieces. I honestly couldn't think of a project that took that concept and just scaled it infinitely almost. The more you break it down into smaller and smaller pieces, the better it is for you, and the better it is for the system to build whatever you're trying to build. Underneath the hood, Bazel computes a dependency graph, right? Now, a dependency graph has nodes. If you're building a monolith, you'll have one node. Cool, it's simple, everything gets compiled together. Bad, because you're compiling everything, every time, all the time. So we're back to the hour plus, build times. We didn't solve anything. Congratulations. So what we had to do in this process was also chip away at our projects, chip away, breaking them down into smaller and smaller and smaller buildable units, which led us to the path to success. So distributed build system, what that means is it'll try as hard as it can to build as much as it can in parallel. This again comes in with the idea of you have more and more buildable units, Bazel will take advantage of that. It'll notice the patterns, it'll notice the dependency graph and say like, hey, so you're targeting this piece in particular? Cool, okay, well I can build everything else that you need in parallel. You don't have to wait for it, right? And another really cool trick, remote cache. This is really useful when you work with multiple people across multiple time zones. What happens is, let's say I put up a pull request, changing some library, migrating it. The next day, 12 hours from now, you wake up and you say like, okay, I think I'm gonna do a clean build from scratch, right? And you know there was this really nasty target that was supposed to be migrated that took forever to build. And like, oh my God, I don't wanna build that. Well, you don't have to. Me having migrated that target and committing that change uploads the build artifacts into a remote cache. It's a bucket, right? It's easy. And then when you build it, you just have to pull it, you just have to download it. And that's insane, especially for large-scale projects that have these cross-cutting changes, okay? So what essentially happened was we took Xcode and we took Gradle and we just threw them off and replaced them with Bazel. Like, that was it. It was almost too good to be true. It's too simple. Our old infrastructure required millions of tens of thousands of custom scripts with people across the globe maintaining them. And then it just turned into a very boring command line. Like, that was it. Just build, target for this distribution channel, whatever. It was scary, right? It can't be this good. And it was, surprisingly. So how we went about this was, during this migration process, we enabled both local development of the system and on pull requests. So what that meant, as an engineer, if you were going to migrate one of your libraries, you could use our local tooling to build said library to ensure that you migrate it correctly. Awesome job, good job. Create a pull request. Let's say you missed something in your local development flow. When you create a pull request, we run the typical number of build jobs with Jenkins pipelines and all that, yada, 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 cool. And it builds the app using the old legacy system. But at the same time, we also spin up the Bazel jobs, right? Which took, I think, a quarter of the time to complete. What this enabled us to do was two things. And we didn't even realize about the second one. We wanted to ensure that we had backwards compatibility. If I migrate a certain library, and you change it tomorrow, I want to ensure that you're not breaking that change that I did yesterday, right? We have to validate that something that was done remains done. What this did, actually, was teach all of our engineers how to use Bazel. We had this entire grand scheme, grand plan of holding up large course and conferences and workshops within the company to teach engineers how to use this. And then we just realized that halfway through the actual migration process, people were already learning by themselves. It was great. People were actively developing and contributing to the migration process. Some teams that we hadn't yet contacted yet to start the migration process were already ahead of timeline. We're like, hey, we're done. Like, can we help with anything else? And this just goes to show the simplicity of Bazel, right? Now, so, okay, I've touted it enough. What makes it so awesome? Well, rebuild only what is necessary, right? It sounds super basic. It sounds like how it should be. And yes, that is correct, except that was not the reality. That is where we had to get to. So, like I said, dependency graph, that is the most critical part of this system, because based on that, it knows what to rebuild, right? If you're doing a small localized change, obviously it's not going to rebuild the entire project, right? Doesn't make any sense. For those of you that have worked with Gradle scripts or make files, Bazel will seem super straightforward. What you do, you create a file, you call it build, and then you specify, I'm going to have a library called my awesome Swift library, and it has these 2 source files and these 2 dependencies. And that's it. Congratulations, you wrote Bazel, and it took all of 30 seconds. It's that straightforward, and that's what makes it so powerful. It scales through its simplicity. It supports major languages. It supports, come on, let's be honest, I think it supports every language. If there's a language, 99% chance there's a build rule for it, and if not, there's somebody writing the build rule for it. And you can link everything together. Like, there's so many bridging systems, and it's just amazing. It can manage over any project regardless of size. It doesn't matter if you're at a startup writing a tiny app of, I don't know, 20 source files, or if you're at this huge megacorp that has a monolithic code base of 200 years old that is running on every bank's backend system. It'll work. It doesn't care. It'll scale. It doesn't matter what you throw at it. It'll build it. And it's integrated with all major IDEs. So sure, you can go full ham with a terminal and go all Vim and build everything from command line. Sure, you can do it. I'm not that good at it. I will not say that I am. I prefer IDEs. I like buttons. I like pretty things on the screen. This is why I got into this industry. And yeah, it integrates with everything. If you got IntelliJ, Android Studio, Xcode, VS Code, doesn't matter. There's a plugin for it. And it's essentially the same workflow. Just hit build, and it'll build, except it'll use Bazel under the hood instead of, the other build system. So from that point of view, this helped a lot with onboarding engineers onto the system itself, right? For Iowa specifically, we're kind of privileged with Xcode, right? It's all we know. It's all we've ever known. Sure, we can do it from command line, but why would we do that, honestly? And it helped a lot being able to build this straight from Xcode. And when engineers felt confident enough, they'd just spin up terminal, because that'd be just obviously much simpler, much faster, easier to debug. So let's take this example. Let's imagine every circle is a buildable unit, right? A library. It doesn't matter. It's source code. Okay. A depends on B and C. B depends on D and E, right? Very super straightforward. Let's say I make a change in the B target, right? Let's say A is like the entire app and B is some framework that we're using. With the old system, what happened was that the entire thing would get built, right? This is a huge issue for projects that scale a lot more and more and more and have more cross-cutting dependencies. And at the end of the day, there's no concept of a dependency graph. Everything gets linked to everything, and it's just dependency hell, right? Well, no. As logic would tell us, only B and its upstream dependency would get built, because C doesn't care. D and E sure as hell don't care, right? And this is by far what saved our butts, right, for such a large-scale project and chipping away at it in smaller and smaller units, sorry. Scale this across tens of thousands of files and libraries and targets, and you essentially get amazing, amazing build times, right? Close to like 80% improvements. We'll get to that in a soon slide. So, cool. We did all of it. What did we have to show for it? It was honestly great. It was the best time to realize that it's quiet and nothing happened. Nothing was our measure of success. Nobody complained anything. Customer support didn't say anything. It was awesomely quiet. Best week of my whole life, because it takes a week to roll out the app in production. You get the point. But what we did was we changed everything and no one noticed anything. It was awesome. The only visual change that happened in our app was a number in a label, namely the build number. And that was it. Our customer support representatives were all super tight, super scared, monitoring the forums. Essentially, everybody was waiting for it to break, because we only had one chance at this, right? This was a switch in production moment. Up until this date, we released from our normal build system. Starting with this date, we attempt to roll out with the new system. there's no other way. Like, we tested it enough. We tested with everyone and everyone's family and their dogs and their cats testing the app. Like, there was a point in time we just had to say, okay, let's do it. Let's go to 1%. So this is the case study. Like I said, for Fitbit Mobile. What we got out of it was improved build time. This was a major issue for us back in the past. Like I said, we had to wait north of 60 minutes, and I'm not making it up, when you would put up a pull request. Like, even the smallest change. Our whole dependency tree and our configuration management was so convoluted and so legacy. Essentially, you'd be like, okay, so I guess today I'm going to write 2 lines of code and go grab a coffee for the next 2 hours, right? Building the app for all our variants, running all of the tests, and that's assuming you got, green builds and you didn't have some flaky test that just suddenly decided to not work that day. This changed dramatically. We had much smaller build times, and we had consistent build times with consistent and predictable results, especially when it came to testing. We had a clear dependency graph. We finally got to see what our app looks like, especially after migrating it. We got to understand what we're changing and how it's going to affect the entire ecosystem. This enabled us to go into a large-scale refactor and rearchitecturization process. So this gave us the confidence of being able to do those changes and clear out those skeletons from every closet, because now we know where everything is, right? It was a large-scale change, which was completely transparent to the user. Like I said, the differences were minimal. The behavior was exactly the same. And that was crazy to hear, because we were pretty tired at this point. We had been working on this project for quite some time. Nerves were super tense. When we hit the 1% rollout into production, everybody was super, palm sweaty behind the scenes, like, monitoring 2 million dashboards. How was our app launch? How's our crash rate? And everything was in line. If anything, for whatever reason, we had fewer crashes, and our app launch took lower. It took fewer time. It was much faster. Everything was better. So overall, it was such a dedicated effort from so many teams across so many time zones and countries, and it could not have been possible without Bazel. This was the tool. This was the process. This was the system that enabled us to do such a thing. And this was the journey. This is how we started and how we ended up. For iOS, we had one monolithic target, so the one with close to, I think, 5,000 files, something like that. The OG project. And around 100-ish smaller targets, static frameworks. We were already in a process for both platforms to break up the monolith, right? But we were nowhere near what we wanted to do. With Bazel at this point, and I think this is already outdated, I think we're close to 5,000 individual targets. So what that means is, previously you had the application target and a lot of other small frameworks, right? Now there's close to 6,000 or 7,000, let's just call it 5,000 for now, individual static libraries that all have their own tiny bits of code. For Android, similar story. One monolith, 150 smaller targets, Gradle targets, and now they're close to, I think they're peaking at 9,000. And this is testament to how simple the system is to use. We didn't automate any of this. I'll be real. We thought about it. We thought really hard. We can do this. There's no way we could do this by hand, right? It's inhumane. We have to automate it, because we're engineers. That's what we do. We come up with solutions for crazy ideas. But we did it because, again, the system is so simple to use. People now just write build files for the heck of it. They just want to try some weird mini demo app, and they pull in this library, and they pull in that target. Oh, and I need this piece of UI. Let me just pull it. It takes 5 minutes. I cannot stress enough how happy the developers are, actually. I remember before we started this migration, we had continuous issues with my build is taking too long, my tests are super flaky, how do I rebuild this, I don't know what's happening. And now everyone is teaching everyone else. There is no longer a team which supports all of our build infrastructure and giving everyone tutorials and stuff. Everyone is teaching everyone else. Our CR builds, like I said, from 1 hour are down like 10 minutes. And this is running the entire battery of tests. There's like 20,000 test suites. I don't even know. Everyone's writing tests like crazy because for once, now it's simple. It's super straightforward because tests are just another library that you put into a rule. And you, instead of saying Bazel build this target, you say Bazel test target. That's it. Oh, not to mention that flakiness is essentially, doesn't exist anymore, right? Bazel has a built-in system where, let's say you have a test case which is flaky, you haven't gotten around to fixing it, it's some super mega asynchronous thing, whatever, and you know it's flaky, like whatever, that is the reality of it. You can mark that test case as flaky, and what Bazel will do is run it 3 times, but not every time. It'll run it the first time, it fails. Okay, cool. It'll run it 1 more time, it fails the second time as well. Alrighty, last chance, it'll run it the 3rd time. If it passes on the 2nd or 3rd time, that's good. Test succeeded. It's just flaky, but it's not gonna block you from doing what you want. It's not gonna block your change. It's not gonna block your pull request. And this helped us a lot in actually tracking down and creating a clear subset of what we know is flaky. At the end of it, we were like, okay, guys, all of this has to go. All this has to be fixed. 0 test suites with the flaky flag. So, one more funny thing. I like jokes. I like to joke a lot. Imagine the car on the left being, it's the family car. It's been like 12 years in the family. It's, it got the job done. It's not super fast. It's not that great. But, it got you so far. And you love it, right? You have a lot of great memories with it. That was our project. Imagine Bazel being like this super custom tooling shop that upgrades your car. It essentially turns the old family van camper into a sick monster truck that can do backflips and go up mountains and fight goats. That is literally what it did for our app. It's been 1 year since we did the migration, and I was having a conversation with one of my colleagues the other day, and we were just remembering how long it took to do certain changes and just release stuff, and it's like a far distant memory. It was so slow, and now it's so great that people just take it for granted. Now we're getting issues like, hey, I think we have too many build files in this area. I'm getting confused about the dependency graph. Like, sure, okay, you can make them bigger or smaller. It's up to you. You can do it any way you want. But that's what it is right now. It's great. It builds fast. It builds consistently. Everything is ultra automated. We don't have to do anything manual anymore. And tests are consistent. It's amazing. That was it. I've been Timo. Thank you for attending. And I hope I managed to charm you just an itty bitty bit more. Maybe try out Bazel. And if you have any questions or you just want to hang around and talk about stuff. I love cats, and I compose music. If you want to talk about it, we can talk about that. But I'd rather we talk about Bazel. Maybe I can convince you to use it. You can find me at the booth. And that was it. Thank you very much.